Hi friends, welcome to GMK tutorials. Now in this video we are going to see the how edge triggered D flip flops are going to be working. So let us see the block diagram for D flip flop. Obviously we know that guys, simple logic for D flip flop. So D flip flops are designed using SR, right? If you know the SR concept, SR flip flops, Q bar concept, SR. Okay, it is a clock signal for positive edge. If you are tying these together with an opposite NAND gate, we can get the D flip flop. So this is a basic diagram. Just SR flip flop వచ్చిందంటే SR flip flops ఉన్న inputs ని complemented version లాగా మీరు అప్లై చేయగలిగారంటే obviously that act as a D flip flop because of in D flip flop is nothing but data flip flop. Okay, what is the input? Same output is present. So SR flip flop when S is equal to 1, R is equal to 0, it produces a Q is equal to set condition. When S is equal to 0, R is equal to 1, it is nothing but reset condition. Based on this S value, which decides the output value. Therefore, input decides the outputs. So we can call it as a data flip flop. So for that purpose, compulsory we need a single input with a complemented second input. So for that purpose S is always complement for R. So here S is equal to 1, it is a complement of 0. S is equal to 0, it is a complement of R. So for that purpose we have to apply the input in the complemented version, then only it acts as a D flip flop. Okay. So let us see the block diagram in terms of block diagram. Suppose if your trading is a D flip flop. So D flip flop consisting of input D, output Q. It consisting of a clock signal. Okay, so DFF I will call as a D flip flop. Okay, it is a positive edge triggered flip flop. We will write in the shortcut. Okay, so because of the time saving, suppose if you are trading the same D flip flop with a negative edge, that is nothing but bubble with. So it is a clock signal. It is a D input. It is a Q value and Q bar. It is nothing but a negative edge triggered flip flop. Okay, now let us see how the circuit diagram is going to be operated. So this edge triggering concept means that suppose if you have a clock pulses like this, okay, but if you are providing D is equal to some value, but without edge of the clock is enabled, okay, this is Q is only activated, only edge of the clock is active. So it is a clock signal. So it is the input. Even though if you are providing the input before the clock pulses, whenever the clock pulse is present, at that time only it is activated. Okay, so that is important. So let us see the circuit characteristic equation table, character CH table. Okay, or you can call as a truth table, characteristic table of DFF. So clock, input, Q and Q bar. Okay, when the clock is 0 or 1, at that time X no change condition. That means the output cannot be changed any value. So because of it is edge triggering, okay. So I will take it is edge of the clock is activated. 0 is the input, Q is the same output. So complement addition. If 1 is the input for D flip flop, it maintains the same output, but Q bar is nothing but complement of Q. So this is nothing but characteristic table for the D flip flop. So the CH equation for characteristic equation of D flip flop can be represented as Q of D plus 1 is equal to D. So whatever the input is there, same input is present at the output side. So that's why it is a data flip-flop. Okay, we can call as a D flip-flop is also called as a data flip-flop. Okay, suppose if you are writing the excitation table for the D flip-flop, so excitation table means that just we can write the what is the possible combinations of inputs excitation table from 2 and possible input combination, right? So this is the so 0 0 0 1 1 0 1 1. When 0 to 0 change transition means compulsory D must be 0. So 0 to 1 transition means that 1 is the input, then only it is possible. So ఇక్కడ అబ్జర్వ్ చేశారంటే ట్రాన్సిషన్ టేబుల్లో ఫ్రమ్ అంటే క్యూ ఆఫ్ టీ అండి. వీ కెన్ కాల్స్ క్యూ ఆఫ్ టీ ఇస్ ద ప్రజెంట్ స్టేట్, క్యూ ఆఫ్ టీ ప్లస్ 1 ఇస్ ద నెక్స్ట్ స్టేట్. సో మీకు అవుట్పుట్ అనేది ప్రజెంట్ స్టేట్ నుంచి నెక్స్ట్ స్టేట్ అండ్ 0 to 0 ట్రాన్సిషన్ జరిగింది అంటే అవుట్పుట్ సేమ్ మెయింటైన్ చేస్తుంది. అంటే అవుట్పుట్ హియర్ అవుట్పుట్ ఈస్ నథింగ్ బట్ 0. So D flip flop లో whatever the output, the same input is there. So for that purpose we have to apply the 0 is the input. So here also same thing, 0 to 1 transition is there. So target system where target value is equal 1. So compulsory the output is matched to the input, therefore D is also 1. So here also 1 to 0 transition, final output 0, therefore compulsory output input should be 0. Here also 1 to 1, therefore we can apply. So this is the excitation table for the D flip flop. Okay, in the next concept we will see how the JK flip flop, that is nothing but edge triggered. Okay, edge triggered edge triggered JK flip flop concept. Thank you for GMK tutorials up to now. Thank you for your support.